Hi, welcome to Unit 5, Day 9. This is Types of Chemical Reactions, Intro to Double Displacement Reactions, Part 1. So this week we've been learning about different types of chemical reactions. And we're learning about these things because by knowing the type of chemical reaction, you're able to predict products and use strategies to balance chemical equations. So far this week we've learned synthesis and decomposition, combustion, and single displacement. Today and tomorrow we're going to learn about double displacement. So specifically for today, we have several success criteria. First, we need to learn how to define a double displacement reaction and precipitate reaction. We'll define what a precipitate is. We'll predict the products of a double displacement reaction, specifically precipitate reactions, and then we'll balance the precipitate reaction using certain strategies. So before we go into double displacement, I kind of want to review single displacement because as you can see, the two names sort of sound alike, and because they do similar things or similar things occurring in both. So in a single displacement reaction, you have an element and a compound as your reactants, and they sort of switch partners to form a new element and a new compound. Now specifically, the element will replace one of the elements in the compound. On the other hand, for a double displacement, you start off with two compounds, so not an element in a compound, but two compounds, and you're going to produce two new compounds when the reactants switch partners. Now, one analogy that we can use to sort of help visualize this is sort of a dance. So in a single displacement, you have a situation where a couple is dancing and then a single person comes along and says, hey, can I cut into the dance? And so that person is cut in and now there's a new couple dancing and then that other person is now left out, right? In the case with double displacement, it's more like two couples are dancing and then they decide to just switch partners. And so that's the sort of the difference between a double and single displacement reaction. Now, before we go into looking at examples of double displacement reaction, there are two main types that we focus on in chemistry, precipitation and neutralization. Neutralization involves the reaction of an acid and a base to produce a salt and a water. We're going to focus on precipitate reactions. So let's look at some examples of precipitate reactions. Now, in the precipitate reactions, which are examples of double displacement or type of double displacement reaction, you start off with two reactants that are ionic compounds, so two salts, and they're dissolved in water, and they're going to exchange partners, and the partners are the metal cations and the non-metal anions to form two new ionic compounds in the products. So if we look at our first example here, which is the reaction of potassium hydroxide and silver nitrate, the potassium and the hydroxide, that is a partner pair. And the silver and the nitrate are a partner pair because this is our cation, potassium is our cation, hydroxide is our anion. Silver is our cation, nitrates are anion. And then they would switch. So you have the cation from the first ionic compound and the anion from the second to form your first product. And then the cation from the second ionic compound and the anion from the first to form your next product. Similarly, with the second example, you have sodium sulfide and magnesium chloride, and they would switch partners to form two new ionic compounds. So once again, you'll just see the metal part switching of the first compound switching with the non-metal part of the second, and vice versa. And then here's our last example. So what we're going to cover in part 2 is how to predict these products. So in these examples, I gave you what the products are, but what if I just gave you potassium hydroxide and silver nitrate? Could you predict these products? And we'll learn how to do that. We're also going to learn strategies to balance these equations. Using the traditional method can be a bit tricky and a bit complicated, so we have a couple of tricks up our sleeves to sort of help us deal with that. So I want to preview what you're going to cover in part 2. So first, you're going to start by learning how to predict the products of these reactions. These are the steps that you're going to follow. You're going to break each reaction down into its cation and anion. And we sort of did that in the previous examples where we color coded it, the metal part and the non-metal part. Then you're going to switch the partners to form products. After you're done switching the partners, you want to check to make sure your products have the correct chemical formula. And that's the stuff that you covered in Unit 4, Day 6. So knowing that ionic compounds have to have an overall charge of 0. And you'll change the subscripts of either the cation and or the anion to get the overall charge to be 0. And then this last step here, which is identifying the precipitate, we're going to do that in the next lesson. So we won't cover that. We're just going to follow these first 3 steps for predicting the products. The tools that you're going to need for that are the common ionic charges and the list of polyatomic ions. After you learn how to predict the products, you will learn how to balance the reaction equations using a couple of strategies. So the expectations, I just want to go over that as well. For predicting the products, you're going to watch example videos for predicting the products, and that will be linked to the practice document. And you'll follow along on a separate piece of paper. Make sure you copy the information down. Now, there are 6 examples, but you don't need to watch all of the videos. You're required to watch 1, 5, and 6. But if you feel that you need to see more examples, you can watch 2, 3, and 4. After you've watched the example videos, you're going to try to predict the products for the CFUs, and you can check your answer using the answer key on the last page, or if you feel like you actually need to see it done, you can watch the video that's linked. When you get to balancing equation, which is the second part, you're going to watch as much of the example video as you need. You may not need to watch very much of it because it's kind of, we've been doing balancing equations, just one simple strategy or one simple trick. But if you want to watch the whole thing, you're welcome to. And then you're going to try and balance the CFUs. And then you'll check your answers using the answer key. So I just want to show you what this document that I've been talking about looks like. This is the document that you have in your Schoology folder. So the first part here, these are the 1 through 6. These are examples 1 through 6. To see the video, you would just click on the link, and then it should take you to for each example. And remember, you're only required to do 1, 5, and 6. And if you want to, you can watch 3, 2 through 4. Then you go down here to the CFUs. These are CFUs. You're going to try and predict the product on your own. And then you can either click here for the video to see it done, or if you go to the very last page, it has the answer key for predicting the products of the CFU. So you can check your answers there. When it comes to balancing, we'll do the same thing. The balancing equation for the example is just one video. So again, you watch as much of it as you want, and you can fast forward, whatever you need to do. And then you'll try to balance the CFUs. And then for this, there's only an answer key. There's no video to show you how to do this. So if you go down to the last page, it has the balancing precipitate reactions for the CFUs all balanced out for you. Also have the answer key for the example problems as well if you want to use those resources. And here, in case you wanted to, you could print this out if you choose and work off of this, or you can write this work down on a separate piece of paper. Finally, there are some additional videos for predicting products. There's a method called the crisscross method that you can use to write the correct chemical formula. There's another video that shows you how to predict the products. It's a short video, so if you're feeling like I'm not really getting it, you can use this if you want. And then there's also a reading if readings are helpful for you. All right, that is it for this video. So when you're done with this, you're going to get to go into the practice folder and begin working on this practice. After that, you'll take your exit ticket. Have a quality day.